So the Sound of Music starts with that, when she's teaching them to sing do, re, mi, let's start at the very beginning, a very good place to start. Hello, everyone. Welcome to the Fireside Chat. I'm Bartha Knoppers, distinguished James McGill Professor Emerita, and the former director of the Center of Genomics and Policy at McGill University. And today, I'm really, really honored to have, I should say, as our speaker and Fireside Chat company, Professor Gerardo Jiménez-Sanchez of Genómica Médica. I will let Gerardo start at the very beginning. Maybe let's say, since we know each other for 25 years, why don't you start back to how you got involved, besides having a degree in pediatrics and in molecular biology and so on. How did you get involved in genomics per se?
Well, thank you, Bartha. Let me just first say that I'm very grateful to be here today on this Fireside Chat, particularly with you. Having the opportunity to talking with a friend for 25-year-long friend is not common, and I'm really pleased to have this opportunity. So thank you for that, and thank you for your question. In fact, indeed, since I was a med student, I've always been puzzled for the molecular mechanisms of disease, let's say. How does this happen? How come an individual can get broken in a way and have a disease? And when I was a med student, the frontier of science was biochemistry and immunology. And that's as far as it would get. And so in order to better understand the genetic examples that we would have available, namely inborn errors of metabolism, monogenic disorders, I started as a student in a laboratory of Dr. Antonio Velasquez in Mexico, who was the leader in inborn errors of metabolism. And from that, I got to get involved in the biochemical pathways and pathophysiology that would explain some of the diseases. But then early in the 90s, I got acquainted with genetics, with what at that time was human genetics. And I remember one day that I attended as a student the meeting of Metabolic Disease Society in Asilomar. That was, I think, 1888, that I heard a lecture, a very inspiring lecture by Dr. David Valley, the Johns Hopkins doctor who was studying at the time different inborn errors of metabolism, and that very beautifully would put together the clinic, the biochemistry, and some of the genetics. So I said, I want him to train me. I want to work for him. I want to go to his lab. And years later, when I graduated from med school and then my residency in pediatrics, I applied to Johns Hopkins to get formally trained in human genetics and molecular biology. And I was very lucky to had the opportunity to be trained by David Valley within the doctoral program in human genetics and molecular biology. And so that inspiration came originally there, and then I had the opportunity to work in different inborn errors of metabolism, particularly in peroxisomal disorders. And the idea here was, let's just not only get to the biochemistry, let's move to the genetics and the genomics. And so I'm talking late 90s at the time. And what was cool at that time was that now we had what we started calling animal models, which was very cool, to be able to sort of disrupt a gene, the gene that you thought was, or that you knew was mutated in your patient, and try to make a correlation between the mammal model and your patient. And that's what I did at David Valley's lab. I had the opportunity to learn what the library was, to clone a mouse gene or several, to knock them out and put them back in stem cells to produce mice with the genetic defects or genetic mutations that we wanted to analyze. So that was very, very cool. And I had the opportunity then to produce single knockouts, then crossing them, having double knockouts, and checking their biochemistry, their symptoms. If you were, I would be checking their temperature and measuring organic acids in urine, and then checking the liver and so on. And we made good discoveries. And then later down the road, but 10 years later, someone discovered a patient with a mutation in that gene in the Netherlands. So,
Ah,
we got to make this connection and publish it together, not only describing what was wrong with the patient, but having this opportunity to explain the symptoms and the metabolic features based on what we discovered 10 years before in a mouse model. So that's how I went from the clinic to biochemistry, the molecular biology, genetics, and then later to genomics. But we're talking late 90s. And of course, what was in the news, what was in the hallways, chit chat was the Human Genome Project coming along. And that was, we were all very excited to see, to know that it was so hard to get one gene cloned and sequenced that took my whole thesis, PhD thesis, and the knowledge that Francis Collins and a huge group of people in different countries were coming to sequence the whole genome. Boy, that was a dream come true. So
yeah.
that's part of the journey as how it started.
So as you know, the Human Genome Map was the final edition was in 2003. So in that decade, um, you're probably also aware, and I think it probably affected how you integrated human genomics into Mexico and so on. You were aware at that time that there was a competition, if I can say that, the race even, as some would call it, between the Craig Ventnor commercial model and the open access data sharing based on the Bermuda Principles of 1996 model. And no one knew, I guess, till we saw them together in the news and on the front of Time magazine, that they actually would be presented publicly as having contributed to the map, irrespective of what some have called the gene wars. But it was a very exciting time. And I think, as you know, because maybe you can tell us, that map led to the idea, well, now it's only a series of addresses, but we don't understand anything. And that's where the HAP map project came. And as you know, because I know that Mexico and other countries worked with the Human Genome Organization, including the ethical and policy frameworks and statements and so on. And for the HAP map, maybe you want to describe some of the dilemmas about how mapping is different from clinical models that find, patients with certain conditions and so on. How did this mapping exercise go over? How did you get, maybe you should talk about Imogen to start, huh?
Yeah. So that was a very nice piece of story that came along. Let me just first tell you that one time I was at the American Society of Human Genetics meeting. Um, One of these moments in life, I was coming through the poster session hallway, and then on the other side there was Francis Collins coming. And I said, wow, this is the guy. I did not know him at the time, but I said, this is my opportunity. And here I go. And young people have no restriction, but we just go. And then at that time I introduced myself. I told him what I was doing. He, as nice and generous and gentle he is, he listened very carefully. and how things are. Then later, a couple of years later, the group I was working with, David Valleys and Barton Child and myself, we got involved in the first medical analysis of the human genome. So as the human genome was wrapping up, we did the first analysis, medical analysis of what at that time were 923 disease-causing genes. So that's what we knew at the time. So the three of us, Dave, Barton, and I, started asking questions from those 923 disease-causing genes. What can we learn that could show us lessons for when the human genome is available? And that was the human disease genome at the time. So for example, we could draw lessons that, for example, from these 923 disease-causing genes, those diseases that were caused by abnormalities in a transcription factor, those peak in utero, where those involving enzymes would peak in the first year of life. Receptors will cause disease between year 1 and puberty, and protein modifiers peak in early adulthood. So those were first lessons that we started learning from this subgroup of genes, as well as the inheritance pattern and so on. And so that work, Dave's, Barton, and my were published in the Green Nature issue of the Human Genome. In fact, I'm the first author of the article called Human Disease Genes, what was the first medical analysis of the human genome on the public project. As you mentioned very well, the Craig Ventures and the Francis Collins projects, the public project I was involved with, and that opened up a series of very fortunate situations through the years. First of all, the relationship that I could establish with Francis till today is being one of a generous mentor that has guided a lot of my, thoughts around what the medical impact of the human genome would be, and certainly along with my mentor David Valley, who could help me craft these ideas. But then coming to your question regarding what happened in Mexico. At that time, I was at Johns Hopkins for over a decade. And then I was invited to Mexico to start discussions on the applications of the human genome. And the reason was that, as we all know, there were 6 countries mainly who were part of the Human Genome Project, not Mexico, not anyone from Latin America, for a number of reasons. So somehow I was called back to my country to sort of discuss, okay, we weren't part of the Human Genome Project. How can we be part of what's coming next? Because how you've mentioned already the way we identify genes at that time, the way we do now, the way we analyze, and it was clear at that time was that benefits from genomic medicine, given diversity, genetic diversity, as a product of human evolution and population dynamics, whereas those products weren't just to be, copy paste into the Mexican population. So they were not like we were used to at that time, by just purchasing items from the US and bringing them down to Mexico, and they would work. So there were initial evidence that either you study your own population, or it will really be left out of the benefits of the human genome project. And I remember very, very clear at that time, we were all discussing on what was going on, and your influential thoughts and work about how to, okay, we need to study people. How do we do it? How are we transparent? How will we approach people? How do we do it in an ethical way? So I remember your voice through P3G and other organizations and your own work as to calling people and say, hey, we need to do this in an orderly fashion. We can't just, grab genomes and go. So let's just be educated about that as well. And let's try to do things with respecting, human dignity and human rights, so that we are also proud not only of the science, but the way we conduct the discovery, the driving products and services, so that we can ensure that the genomic medicine and genomic benefits are for all. So I remember that, and before I jump to the Inmehen story, I really want to make a quick stop here and say how you influenced the way we started analyzing populations outside of the United States, and how the notion that we could do it in an orderly fashion would be very useful. So thank you for that, Bartha. That was key for me, for my group, and for the world, I know.
Thank you, Gerardo. Well, before we talk about the National Institute of Genomic Medicine, known as INMAGEN, there were also specific contributions to you'll remember in 2007, the UK Biobank started discussions and was created in 2009. We had the population study in Quebec that I headed up called Cartagene. There was Estonia, way ahead of all of us, doing their national, and not only was this concept of population genetics or creating biobank resources for others, nothing to do with a specific disease, nothing to do with you. It's you as a citizen saying, yes, you can use my genome in order to better map for better science, including clinical applications in the future. But Mexico had some very interesting approaches. Maybe you want to describe, because today, as everyone's saying, polygenic risk scores, we need more diversity in data sets, we need more populations participating. You started with a very unique approach to do that in Mexico. Maybe you want to talk about that a little bit.
Well, yes, thank you. So as I said, my former mentors in Mexico, particularly Professor Soberon, who was a former Secretary of Health, a former president of the National University and institution creator of our in our country, he called me back several times and say, okay, keep me posted as to what's going on there in the human genome. And I remember one time in 1999 that I came back for Christmas to Mexico and met with him. I said, there are these SNPs that are beginning to pop up in the human genome that we are beginning to identify in a systematic way. And it turns out that they have to do with what we call biochemical individuality. So that was started before, and how patients respond in a different way to the same treatment, and how some people have risk for certain diseases and some others don't. Well, it turns out that these one letter change happening throughout the human genome provide you with a unique code that, in combination with the environment, provides you with the specific risks. So here, this very smart man, along with others that I've already mentioned, go, well, that could be a transformational tool. If that were the case, we need to know first of all, what is the catalog of those SNPs in the population? And second, which of them are really related to biochemical individuality that really makes sense or can be useful to prevent or treat disease? So with this conversation, we started working around studying and developing genomic medicine for Mexico. Now, we did it, in fact, in a very organized way. First of all, we invited colleagues from around the country to ask for opinions and reflections as to how to do this in Mexico. Then they decided that there would be they created what they call a consortium for an Institute of Genomic Medicine established by 4 institutions: the Department of Health, the National University Autonomous in Mexico, the NSF equivalent in Mexico, CONACYT, and the private sector grouped at the National and the Medical the Mexican Health Foundation. So they established a consortium of which they named me director. And the goal here was to recruit elements, individuals, and all of the gadgets that we might need at that time to create an institute for genomic medicine. I remember that McKinsey and Company came on board as a pro bono project to help us, shape this idea. And yes, after we started having a temporary facilities with genotyping units and so on. And then in 2004, the Mexican Congress created by law the 11th NIH of Mexico, the National Institute of Genomic Medicine, which was created based on the work of the consortium. And so by that time, we already had identified what were the challenges, the initial research projects, the human resources that we could integrate, either being in Mexico or recruited from abroad. We established at that time a pretty robust network, including certainly Francis Collins, David Valley, who was the chairman of our scientific advisory board, Aravinda Chakrabarti, Eric Green, and some others that were very keen on helping us construct this institute. So
you had a particular approach, I remember, because as the HAP map was going on, which it's an epidemiological project. There are no drugs, no devices, nothing you can give to people. And I remember when you decided that in Mexico you would include from the beginning your indigenous populations. You had a particular approach to their participation, which I think is really probably still what we should, use today. So go ahead and tell us what you did specifically.
So, like you said, probably project 1 was get to know the genomics of your population. So at that time, like you mentioned, there was the HAP map coming up very vigorously, which basically was, let's analyze what the DNA structure is for what they call the original populations, namely African, European, and Asian populations. And so the notion behind that, let's just try to construct a map of haplotypes that are chunks of DNA which include a number of SNPs, and they are inherited together as a block through generations in that population. So those were 3 what we call original pure populations. So we say, well, in Mexico, we don't have such a pure population as most dominant population. In Mexico, indigenous populations are an integral part of the national's identity, history, and culture. And we have over 68 recognized indigenous groups speaking more than 350 dialects. They represent approximately 10% of the total population, which is about 12 million people in the country. So each community has its own unique cultural heritage, traditions, and genetic makeup, contributing to the rich diversity that defines the Mexican population. So our approach had to include them, not only because they are an essential part of our population, but because they contributed to the genetic makeup of our population as we are today. That is to say, most of the Mexican population are mestizo. We call it mestizo, which is the admixture of European, particularly Spaniard populations with indigenous populations. So here we are with the challenge of analyzing the hap map of a population that is not pure, that is clean in the sense that they have been conserved through generations, but as opposed to that, a population that within the last 5 centuries, they've been mixed with different groups and Spaniards. So it was a pretty complex puzzle, and we decided to invite people to be sampled both from the mestizo group and the indigenous group. And we didn't go to the 68 indigenous populations. We decided to invite some of them from the north, south, east, west, and center, just like that. And we did exactly the same for mestizo population. And what was interesting here was the approach. And again, we reviewed very thoroughly the literature and the other experiences in the world as how to approach these populations. And what we did, we had to be very careful here because we really wanted to establish a bond of trust. And we really wanted to make sure that there would be mutual benefits, even though, like you said, these projects were not after a specific applications for healthcare. They were aiming to having a platform, an initial platform from which we would be able to construct and establish synergies with the rest of the world. So we decided to take several approaches. One is that we would approach communities, which, by the way, are remotely established. It's not easy to get there. So we would go there and we talk to the individual or individuals that they decide were their authorities. And in many cases, we needed a translator. And they would ask questions given the history of abuse in different ways that these underserved populations have gone through. So, however, to my surprise, those communities became really interested in what the project was about. And lesson number one is, don't have prejudicious concepts about those indigenous populations. They are as smart as we are, if not more. They have a very well established structure as we do. They have their own language as we do, and they have their own identities as we do. So approaching them needed to be with respect, needed to be in a one-to-one basis, and needed to be in person. So many barriers we might imagine, such as lack of understanding or resistance to participation, really didn't exist as such. So as we were approaching, eating around their tables with them, I remember one time in the Mayan population that discussions took place in a cave. We needed to go down several meters underground in a cave that was dark, with only the light of the sun that came from the hole through which we went through. And we discussed human genome, we discussed genetic variation, SNPs, and human disease. And we used simple words that they were able to, to use to adapt to their, or to understand through their culture. So the key is to find the appropriate channels of communication, respecting each community's tradition, culture, and decision-making structures. So this includes understanding their history, consulting recognized authorities, providing translators when needed, and offering materials culturally and linguistically appropriate for them. So we, for example, produce a comic or several comic books so that we could remember that, yeah, so that we could start from a drawing. And then we had to get to a more complex situation, which was a consent form. And consent form for a hap map wasn't easy, was a pretty complex document that needed to be understood. And so what we did is that after discussing the consent form, we modify or adapted that LC consent form into a Q&A, into a questionnaire out of 12 questions, straightforward questions. What are my rights? What are your rights? What kind of sample? What am I getting out of this? Will it hurt? Who will be conserving the sample? Will my sample make it to the map, or will it not necessarily make it to the map? What happens after you take a sample, and so on. So we establish a sometimes 12 or 15 question answer, and we translated that. That was not only in Spanish, but we translated that into the local indigenous language and produced huge posters that we posted across the community a week or two before a sample taking day, so that they will have plain liberty to discuss, to read, because they read and write, of course, to read, to ask questions, to consult with their own authorities, and so that when sampling day would come, those who show up would be completely informed about what this was about. And even though there was a table with my colleagues before the sample collection station where they could come and still ask questions, whether in Spanish or with a translator, and they could still there say, no, I don't want to. To my surprise, most of them did offer an anonymous sample, and we signed consent forms and provided them with a copy, and we kept a copy of it. And we use those samples to get the material for our HAP map for the Mexican population. So this was an initial catalog, an initial map of the genetic variants in Mexico. And in the PNAS paper that we put out with this project, clearly we show that in fact, we're not just a copy-paste from original populations. In fact, we show that with the data of the HAP map, we could show how we were mixture of those ancestral populations plus others. And that supported the notion that genomic medicine was not a copy-paste opportunity. It's not a copy-paste thing that we could do from developed countries, that in fact we needed an institutionalized way to approach genomic medicine for our populations. And so that was one of the major projects of INMEGEN, the National Institute of Genomic Medicine, when I was serving as director.
It was probably, I don't want to presume anything, but it sounds as the most enriching experience that you actually would go into the communities, talk to the people, and then those who wish to participate could ask further questions, and then they could participate or not, and so on, that they understood the concept, that was not, you know, something level of complexity. Other population projects, as you know, even if you look at UK Biobank, they had a 6% collaboration rate, as we say in epi language. Quebec, we were fortunate. We did a year of consultation. We had a 27% collaboration rate. And I think Estonia, which of course did it all through their medical system, through the clinicians, I think had even a higher one. But all of these routes show that there's not one way to ensure diversity. It's like you said, through respect. Once they see that you respect them, and that you get their trust, and then the experience they have reinforces that trust. And with the modern sort of genomic medicine, if I could move on to other subject, I note in your bio that you also are involved in a direct-to-consumer, which is going straight to the person. You don't have to, well, I went through 18 ethics committees for Cartagena, okay? You know, direct-to-consumer is you go right to the person, they say yes, no, maybe so, or whatever. How does that contrast, that direct to the individual, with your community experience that you had with the indigenous populations?
So, very good question there. Let me just one item that you're bringing up that I want to wrap up the indigenous population story with is that when we finished that part of the project and published a PNAS paper, which is not a simple piece of paper to read by the general public, we decided to not only translate the PNAS paper to Spanish, but produce yet another comic book to explain the results. And there was a big ceremony with President Calderon and President of Mexico, where I turned a whole package of with the results of the project. So we decided to produce that very same package by thousands with the translation of the PNAS paper and the comic book and access to the database, and go back to each one of the indigenous populations once and again, the whole team, to sort of explain the results. And here we are in very rural areas with drawings and graphs explaining what principal components graphs would mean and where they would be in the graph and what this might mean for the future. And let me tell you that their sentiment, their appreciation for being taken in consideration, just the same individual who was in the news with President Calderon turning these results to him was at their communities. The same people who asked for permission were coming back with the results, with the comic book, with a Q&A session for them, given that they were an essential part of the project. So to me,
isn't that a wonderful form of benefit sharing? I know that the pandemic treaty instrument is held up right now at WHO because everybody wants to know what's in it for me. How much percentage can I get if I do send my variant to the WHO database? Blah blah blah. The what's in it for me. In contrast, the way that you did it, the real benefit sharing was one, being respected, two, being appreciated, three, being informed of the results and being able to query about the results, and probably being very proud of having participated. And there was no exchange of money or percentages or biomanufacturing plants that were promised that were never built or whatever. So it's really interesting that the notion of benefit sharing, I think we really need to expand it to include different models, considering the success of your model. So let's get back to the DNA direct sort of thing.
yeah.
What's your
So
experience?
So yes, as a researcher, as a physician, as an individual, this was a very rewarding process that I went through, and I was really blessed with this opportunity. So the next question, and then of course, in my hand, after my tenure as director has moved along very successfully. Let me just say that since we established it, there's been over 1,500 scientific papers coming out from Imagen. And yesterday I was reviewing that there's been 1,203 theses in genomic medicine coming out of from Inmegen. So this institute not only has thrived, but has creating benefits for the Mexican society, not only through discoveries, but also through training people, having graduate courses, and so on.
Okay.
So in continuing with the initial idea as to how do we go about learning about molecular mechanisms of disease? How do we went through that through the bedside, to biochemistry, through genetics, through genomics, through the population genomics. So it was about time to come back and say, let's just go back to bedside. How can we go back and bring those products and services to the individual? Now, in any country, but particularly in emerging countries like Mexico, given these task to an NIH is unjustified. That is to say, it is unjust. They're not created to to produce goods and services to serve everyday lives of Mexicans. So we really needed another tool that would complement science, would complement our institutionalized research in genomic medicine to draw testing for the population. So we decided to create a company, a number of companies, but a company to start with, that would be able to use our genomics infrastructure to create a new genomics infrastructure and bioinformatics based on our previous experience and bring those tests to the public in a way that could be accessible to many, not accessible, and I should recognize to the base of the pyramid, but we decided let's just start from those that we can serve right away. And so we developed a DNA testing kit based on different materials that could be purchased online or directly in our lab. The lab is called Genómica Médica, and so that people would kind of either come and do their test or order the kit and send it over so that the saliva or swab will come through FedEx or whichever courier, and we'd be able to analyze it based on the disease that those physicians or individuals were interested on. We certainly follow not only the FDA equivalent COFEPRIS regulations in Mexico, but we also follow, again, the ethical and legal forms that we had to make them aware of what it means to doing a DNA test, of asking permission as to whether or not keep their sample for a number of months, whether or not they want to leave an anonymized sample for research to the future, and certainly that again make people feel that this was being done with very respectfully. Now, when the other day we did a study as to who's purchased our kits, whether it's simple tests, either paternity kits, for example, to complex whole exome or whole genome tests. So we did an experiment, Google mapping our customers throughout Mexico. And to my surprise, there are many communities that have no running water, no roads, but they are in agriculture. And what happens is that many migrants to the US go to the US, get acquainted with the knowledge of genomic and testing. They come back to their communities, educate their communities, and when there is a sick individual, they will order a kit through their telephone, through internet, and we will ship it over there. They would take the sample because our kits have a QR for a video as to how to take a sample, and they will ship it back. So it is interesting how my Mexican fellows with education from circumstantial situations will come back, educate, and make a benefit to their society, to their community. So I can tell you how many monogenic disorders we have diagnosed through those kits, and how many more complex disorders, very rare, we have made. Paternity testing, pharmacogenomics testing for people who don't respond to a to specific drugs in psychiatry and other disciplines. So when you get to see the impact of this startup, because it started as a startup, then it grew up, but the fact that this entrepreneurship experiment could lead to giving people access to the actual benefits, it is just an example, a trial of what we want. Today, our kits are not only sold online or at our laboratory, but there is in Mexico a large chain of department stores like, Macy's or Nordstrom in the US, where people can go to their pharmacies and purchase one of our kits. And they can take a swab and send it over to ask for a specific testing. So we don't do ancestry, we don't do recreational genomics, we do very specific diagnostics, and it is amazing what we've seen.
Talk about integration into the general culture. This is so important, this normalization of a genetic test, of genetic data, when combined obviously with medical records or familial history and so on, or environmental circumstances. But the more we can integrate and get away from the genetic exceptionalism, that it's something bad, that it's something that's going to be misused, that it can wreck your employment and insurance potential, that it's going to make you feel guilty, that it's going to force you to tell your family, the more we can normalize genetic testing in the healthcare system or through consumer behavior. They're not all patients. A lot of people are resistant. Not everybody's susceptible and going to have a late onset disease or whatever. I think that's so important in a culture to be able to do that. And that leads me to my last question, which is, I'm not sure I've been for the last, I don't know, 30 years or so, 25 years, ascribing to you a quote. It could have been Victor Penchachez from Pau, and I'm not sure which one. It was way back when we worked together. It was about newborn screening. So let's get back to the public and the population again, but this time to your first love, which was pediatrics, right? So as you know, it's metabolic or mass spec or biochemical tests. And the beauty of newborn screening, which is the most successful WHO public health population endeavor in the history of the WHO, is that it looks for asymptomatic, at-risk children, sticking to newborns for now, in the general population. Then you do diagnosis, then you do confirmation, then you do this. And you said to me, I asked once, what happens if a country can't afford the PKU diet or the treatment for hypothyroidism or today SMA, let's say? And you said to me, the beauty of the newborn screening program is finding the at-risk child, because using this public mandate, this power of the state to initiate this in the name of the at-risk asymptomatic child that we need to find, is that we find the children who are born. In other words, it's almost like that you get to know that child exists. Was that you who told, when by going into the countryside and into the communities, the public health nurses doing the heel prick test? Is that like, did you say that to me, Gerardo?
Well, I don't know whether it was me or Victor, but that will certainly apply here. The fact that you can identify an individual from early age that has a special need, and that you care and go after that individual and provide the treatment timely before it's too late, given the central nervous system damage that the disease will create, that as a fact is extremely powerful. Not only today I recognize that it is not only because you identify and help that individual, but you get to identify a family that it is carrying a gene that need a genetic counseling, because there are options for that couple to prevent having another child with the disease, or at least to know that the coming child will have the disease, and provide them with the support that they might need. So yes, I see that initially. Now we do genomic testing for newborns, so it's a more robust way. And again, moving from the biochemistry to Guthrie to this and that, and today now we can use with the same blood spot read so many genes. Indeed, I believe that is extremely powerful, and that's another underserved population many times, which are the newborns. And so if you are able to get to them and help them out from the very beginning to get a healthy start, that is extremely powerful. And that's something as a pediatrician nutrition that I love. But
Yeah, I don't know. I think this is probably the first time you'll ever hear me say something negative about genetics or genomics, is that there is now a fear that by adding genomic sequencing to the biochemical and the mass spec and so on, some of which are technology specific to finding certain conditions, that people say, oh no, you're going to put my child's genome into the medical record. And they somehow fear that that public population successful newborn saving program will be destroyed by adding the genomic label to it. What do you think about that?
well, I think that science need to help public policy and inform public policies that so that we can prevent things bad things from happening. Not necessarily saying that what you're saying is bad, but those fears from society, and you might remember the kind of fears that people had at the beginning of the century, whether this was cloning, whether this was preventing you from employment and discrimination and access. So I think that with information and time, humans as a society, we've been able to pass very successfully hurdles and fears that we had at the beginning. And so to me, the answer is not only to have to detect fears, but to have information and as a society to discuss what's acceptable and what is not acceptable based on our culture and principles. And as I said before, respecting human dignity and human rights. If we are able to construct a dialogue with those who craft public policy and you educate those public policies sustainably with as more information is coming, we will prevent those and other fears from happening to becoming a reality. So I
I think
after
that's the
20 years,
goal of the Global Alliance for Genomics and Health, of which you and I are both board members. And I think that's that bridge. Remember, the title of the framework is the framework for responsible genomics and health related data, the use of genomic and health related data. So we get to the health. And I think that bridge that the GA4GH brings internationally, bringing different communities together, is exactly that translational bridge and the tools for both policy tools, but IT tools and so on. Now we have two questions here, but I'll put them together. You see it on the chat probably. How can you expand your model of genomic science to smaller populations in Latin America and or the Caribbean that have fewer healthcare resources? And the other question, and what's happening to your Mexican genetic variants? Are you putting them with other public databases like ClinVar? Are you sharing them with the broader community? And you have 5 minutes to answer that question.
So I'll take two or three so we can wrap up. But I will say that as we were blessed with constructing the Institute of Genomic Medicine in Mexico timely in year 2004, that created a ripple effect through Latin America and the region and Latin America. And so that created the curiosity and awareness of the need of establishing organizations devoted to genomic medicine. And in Mexico, it couldn't have been possible without the leadership of Secretary of Health Julio Frank, who then became dean at Harvard School of Public Health and then became president of the Miami University, and in January becoming the 7th chancellor of UCLA, a very wise man committed with science and public health. And given that he was a Secretary of Health, he devoted the resources for us to develop the INMEHEN. So that's a very unusual case. When individuals in other countries, smaller communities, have the need and interest of developing genomic platforms for their communities, I'll say now the landscape is very different. Now you have INMEHEN on the one hand who love to establish alliances with other countries and community. So knock on the door of INMEGEN, particularly the director, who is a genomics and oncologist and understands this very well, Dr. Jorge Melendez. He would be happy to hear and to collaborate. And two, now we have global alliances like GA4GH. So I will encourage my fellow Latin American colleagues to knock on the door of GA4GH and get to browse and to know what we have, what GA4GH has constructed. Standards for data sharing, ethical governance, equitable access to genome research frameworks. So you don't need to reinvent the wheel. We've done it for you. So knock on the door, be part of the alliance, raise your hand, and I'm sure GA4GH would be happy to hear from you and show what it's available for your own use, and also invite you to join with your experience and community. So the landscape is very different, and I would advocate for more alliances, particularly with these two organizations that I know well and that are open for alliances. And I will say that specifically because the challenges now are different. The challenges are different from 20 years ago, as those that we talk as our history, but now we're facing genetic risk scores for disease stratification, ability to diagnose most of monogenic disorders, designing drugs for specific mechanisms of disease, creating equitable and effective healthcare solutions in different countries. So let's just learn from those countries and societies who have been successful in creating those instruments. And by the way, INMEGEN, for example, is already assessing or assembling tools for genetic risk for the admixed population in Mexico. So I would say, let's just knock on their doors, let's just add to the alliance and use what it's available, which is way more than what we had 20 years ago.
Really quick question. Do you deposit in ClinVar? And secondly, how do you protect the personal data of participants who are not anonymized in your database?
So let me just say that after our initial project, other very serious projects had arisen from alliances in North America, that is the US and Mexico and other countries. So today, and particularly this year, two big science papers came out with Science or Nature papers came out with much more denser information of genomic features of the indigenous and mestizo and Latin American population. So those are public. Ours were, yes, indeed, made part of the large data sets. They were anonymized when they're used. That is to say, we didn't know which of the samples made it to the map and which didn't. And that way, we contributed with that information based demographic information, but not anything that would identify individuals.
So do you send data into ClinVar and so on to contribute to the variant databases?
At that time, there was no ClinVar. So
I know today, I mean today, of course.
Today,
Yeah.
I don't know, we would need to ask INMEGEN, but I will think so, yes.
Okay, that's true. And so you think that the data protection currently offered to citizens in your country with respect to their participation in research, or more importantly, the emergence of genomic testing in the hospitals and the clinical setting, those data now going into the records and then going into quality assurance databases. You have a system in Mexico for the protection of personal data?
There is indeed a system, a national system for the protection of personal data that we are by law obliged to follow. And so certainly not only includes genomics, but all of the personal data of an individual. So yes, indeed, there is. However, I do think that we urgently need to continue informing public health to get to specifics regarding genomic data. because we need a particular chapter for genomic data, given all the variants that arise from genetic data. So there is one, but I don't think there's one specific for genetic data yet.
Yeah, and a lot of the tools and systems, and you mentioned the ethical provenance tools that came out of GA4GH that now will be put into an IT tool and under a different grant may help us be able to follow and protect the data in a responsible way, especially internationally. Gerardo, if I may call you by your first name, since we've known each other so long, it's been a real pleasure, and I'm on behalf of everyone on these fireside chat, but also for myself, I can dream of another 100 projects that we can do that will have the impact, international impact, because of visionaries like yourself. So thank you for being part of this fireside chat. Thank you.
Thank you, Bartha. It's been an absolute privilege to participate in this fireside chat alongside my admired dear colleague, Bartha Knoppers, whom we've worked together for over 25 years. So let me just say that your remarkable insights and unwavering dedication to advancing genomics continue to inspire me. So thank you, and thank you to GA4GH, not only for this virtual but transformative platform that you're putting together, and thank you to the nice comments that are coming up in the chat.
Thanks everyone. That's truth for your comments, and long live international collaboration.
Absolutely. Till next time, dear Bartha.
Till next time, Gerardo.